Hi, my name is Dwight Dunn, and I'm going to be offering a 6 weeks calculus fundamental course addressing the basic differentiation techniques. Course is ideal for students who are desirous of pursuing Calculus 1, AB Calculus, or Advanced Mathematics and just want to learn the basic differentiation techniques that's going to be useful for any major calculus course that you're planning to do. So this is awesome for students who are just getting started out and just want to learn the techniques step by step. So that's what we're going to be doing. We're going to be addressing the basic differentiation techniques. So let's get started. What we're going to be doing now, we're going to start off with differentiation from first principle. Or we could say we're going to use a definition of derivative to actually differentiate specific functions. And we're going to stick to basic functions. We're going to start with just basic algebraic functions just to show how this technique is actually developed. So this is where differentiation pretty much begins. And this is where we're going to get started. So let's consider the following. Let's consider the diagram above. Now, from most fundamental courses that you have done before, you have been taught that the slope is the change in y over the change in x. So we understand that the change in x is simply going to be the distance, if I consider these two endpoints, the distance or the horizontal distance between these 2 points that I've highlighted right here, and the change in y going to represent the vertical distance considering these 2 points right here. All right, so to make that clear, so what we're going to be looking at now, we're going to be looking now at the following. We're going to try to create the situation that give rise to the derivative at a specific point, or in some books or in some cases it's called the instantaneous rate of change. So let's consider the secant line. Now, what is a secant line? A secant line is simply a line that is connecting 2 points on a nice smooth curve right there. Now, if I consider that particular secant line for those 2 points, I realize, creating this specific example, that my slope, in other words, my change in y over the change in x, is going to be 24 over 15. Now we're creating that situation to use for this example. So my goal now, if I have this secant line, I am desirous of finding the derivative, say at this particular point right here. So to find that derivative at that particular point, what I'm simply going to try to do is try to create a line of tangency at that point, something looking like that. And then from there, I am going to use the secant line by minimizing my y values and minimizing my x values to get that perfect tangent line. So let's go ahead in terms of how we're going to do that. What we're going to do, if I just back up 1 second right there, I am going to have multiple lines or multiple secant line, trying to draw them closer and closer to the perfect line of tangency. Would be looking something like that. Now note, the line of tangency is simply a line that touches the curve at one single point. So if I'm able to determine the line of tangency or approximate the line of tangency using the secant line, I am able to actually determine what would the derivative be at that particular point. Now let's keep it going. So here, my delta x here would be considered to be my change in y that I'm trying to minimize. I'm trying to minimize the change in y, and also I'm trying to minimize my change in x, starting from multiple secant lines there and trying to approach that specific point. So looking at that example, if I back up, I realize that my change in y by change in x, if I go back to my basic algebra course, I know is equal to y2 minus y1 over x2 minus x1. So that there represent my slope. Now, if I consider this to be my original point, that my original point going to be x f of x, because f of x is there representing my y value, and I use this basic formula for the slope, I recognize that f of x minus delta x going to represent my change in y. And please note that here I have f of x as my original point, and I'm adding an incremental, very, very small change in the y value right there to actually get the change. So looking at the slope, if I consider f of x plus delta x to be y2, so consider y2 to be equal to my f of x plus delta x, and consider my y1 to be equal to f of x, and also I have x right there, and I'm going to have for my x2 to be equal to x plus delta x, and obviously my x1 going to simply be equal to x. Putting these things into the formula y2 minus y1 over x2 minus x1 going to yield this formula right here. If we can see that. Now again, delta x there is represented my incremental change in x and y, because x plus f of x plus delta x would represent my change in y, and delta x would represent my change in x. Getting that formula, my goal now is to actually shrink or minimize my delta x. So I'm going to approach 0 or try to get it as small as possible to 0. That is how now I'm going to create the definition of the derivative. And to create the definition of the derivative, I recognize that delta x over x equal to f of x plus delta x minus f of x over delta x going to become this formula. Now, I want to compare this formula because you probably are wondering, why did I use h and why do I use delta x? Now, when you're working out a lot of problems, it is very difficult sometimes to differentiate between x and delta x. So I change my delta x to h. Just be aware of that. I change my delta x to h. So all my h is the same thing as delta x. Now, since I want delta x to approach 0, I have replaced the limit sign. So the limit here as x tends to 0, that is representing me approaching 0 for h. So I'm taking the limit of this as h tends to 0, which is representing now the derivative. And this is what we call the differentiation from first principle, and in some books we call it the definition of the derivative. I hope you enjoyed the first lesson, and this is my hope to actually give you the fundamental differentiation technique for calculus, trying to give you the basics and keep it moving. All right, see you in the next one.